Okay, guys. So, yeah, here we are starting off with radioactivity. First thing you need to identify is basically the detail about the structure of an atom, where you say that the nucleus is dense. There are two reasons for saying nucleus is dense. First of all, the size of the nucleus is really small. And whenever I say small or big, it's a comparison. So it's very small in comparison to the entire size of the atom. And of course, atom is itself very, very small. But when you make a comparison of the atom with the nucleus, so the nucleus is very small in comparison to the whole size of an atom. And so you can even see it over here that the size of the atom is 10 to the power 5 times the size of the nucleus. So that's like 100,000 times bigger. Let's say, you talk in terms of making a scaled model. You think of planning to make a model of an atom, and you decide that you'll make nucleus of 1 meter diameter. Then you have to make an atom of 100,000 meters, 100 kilometers. That's like a very, very big number. Just to give you a bit of an idea that how small a nucleus is. So the two reasons for saying that the nucleus of the atom is dense, firstly, because the size is really small. Secondly, because most of the mass is concentrated inside the nucleus. That's again because the particles which are there in the nucleus are protons and neutrons, which are very, very massive as compared to the electrons. So then again, as I say, massive or big, it's a comparison. So the mass of the electron is very small in comparison to the mass of the proton or neutron. So I've given you that comparison as well, that mass of electron is approximately 1 upon 2,000 times mass of proton. In simple words, if you could make a very small physical balance and sort of try and balance out electrons and protons on two sides, then you have to approximately put 2,000 electrons to balance either 1 proton or 1 neutron. This is just to give you an idea that how massive protons and neutrons are in comparison to the electron. So this explains the term dense nucleus. Dense because of two reasons. One is the nucleus is extremely small. The second is that most of the mass is concentrated in the nucleus. That's because protons and neutrons, which are there in the nucleus, are a lot more massive than the mass of electrons. And then the other thing you need to identify is that the charge of the nucleus is positive and the charge of the electrons is negative, because the nucleus contains protons and protons have a positive charge, and neutrons have no charge in them. So therefore, the total charge of the nucleus is positive. And there are electrons with negative charges orbiting around the nucleus. So for a neutral atom, and the charges are equal, the charge of electron is equal to the charge of proton. The masses are different, but their charges are equal. So for a neutral atom, if it's not an ion, the number of protons must be equal to the number of orbiting electrons. So you will say that the atom is neutral. If it's an ion, so it probably may have an excess electron, which will make it negatively charged ion, or if it has one less electron, so that will make it a positively charged ion. These numbers you have to remember over here, that this is not exactly a value, because different nuclei will have different sizes, but the order of the size of the nucleus is 10 to the power minus 15 meters, and the whole atom has a diameter of the order of 10 to the power minus 10 meter. So, and that again tells you the comparison, or re-emphasizes on the comparison, that the size of the nucleus is extremely small as compared to the size of the atom, which I've tried mentioning here, that's like 100,000 times bigger. The next thing you need to identify is nuclide notation. So a nuclide notation is basically a way to represent the element and telling a bit more detail about the composition of the nucleus. So on top, you write the mass number, and at bottom on the left-hand side, you write the atomic number. Atomic number is how many protons are there in the nucleus. And the mass number is the total number of nucleons, which means it is the sum of protons and neutrons both. So that's how you can find out the entire composition, because you know the number of protons by atomic number. And if you do A minus Z, you will also get to know what is the number of neutrons. The other thing you need to identify is what are isotopes. Isotopes are those atoms which have same atomic number. That is because of same number of protons, but they have unequal mass numbers. That's because of different number of neutrons. An example could be carbon 612 and 613. So they're both carbon and they have both same atomic numbers. That means they have same number of protons. But if the mass number is 12 and 13, so that's indicating that one isotope of carbon has 6 neutrons and the other isotope of carbon has 7 neutrons.